Okay, this is going to be a quick one. So we're doing graph interpretation just like I promised. We have f of x equal to g of x, right? That's the first condition, by the way. Whenever you see this in your functions, f of x is equal to g of x, this means that g of x and h of x meet or touch. They're actually crossing. For instance, if you have two functions, a parabola and also a straight line, right? Let's call the parabola f of x and then the straight line g of x. This point, this is where g of x is equal to f of x. So that's what we talk about when we talk about the intersection of g of x equal to f of x. This is where g of x and h of x meet or touch, right? That's what this means. So let's go to the second condition. We have f of x is greater than 0. This simply means where f is above the x-axis, right? So let me explain this on the other side. Okay, so we have our descent parabola f of x right there. So when we're saying we want where f of x is greater than 0, we're saying we want this region of the graph, everything that is above the the x-axis up to infinity, because our parabola extends up until eternity. It doesn't stop, it's continuous, goes up there, up there, up there, up there into the afterlife. So this is our parabola. So this is where f of x is greater than 0, right there. Remember, f of x is y, so we're looking at the y values. The y values are greater than 0 starting right here, right? Do you see that? Right here, or let me just say right here, upwards, or right here, that point where y is equal to 0. This is where y is equal to 0. Anything on the x-axis, anywhere at any x value on the x-axis, y is equal to 0. So it's going up there, up until eternity, infinity. It doesn't stop, it's continuous, it doesn't stop. So that's what it means. And then we go to the third condition, which says where f of x is less than 0. So we're looking for where the graph is below the x-axis, right? So let me draw another parabola and show you what I'm talking about. Bear in mind, all these conditions apply to parabolas, hyperbolas, linear functions, exponential functions, cubic functions. They apply to anything that is a function. So remember these conditions, keep them in your mind forever. Okay, to keep things interesting, I actually decided to draw a linear function instead of a parabola so that I can see and help you understand that this is actually applicable to every function that exists. So we're asking for the region where f of x is less than 0, right? So you are looking at everything that is down here, right, at this region, yeah, below. So if we were talking about the graph, specifically f of x, we would say it starts here, right? Let's say that is 1 and 0. Those are the coordinates, right? 1 and 0. So you'd say that this graph is actually less than 0 where x is less than 0, right? We're saying less than 0 because at this point right there at 1, excuse me, where x is less than 1, sorry about that. So if they were to ask for which values of x is the graph below the x-axis, if they were to ask for this condition, right, you would say it's where x is less than 1, or where x is an element of 1 up to negative infinity, because our linear function extends forever, right? It goes on forever and ever, right? So let me talk about this inequality sign. I said less than because at this point, specifically at this point, the graph is not below the x-axis. It's actually touching the x-axis, and they want where it's below the x-axis. So we have to exclude 1 because at point 1 it touches the x-axis. It's actually equal to the x-axis. It's not below, right? So it doesn't count, right? So yeah, if they said equal to, you'd actually include, your answer would go to this: x is less than or equal to 1, or x is an element, square brackets, of 1 up to negative infinity. You always exclude negative infinity. You'll never touch infinity. It's impossible. That number is out of reach. Even if you can't, just forget it. So yes, that's what it means, right? When f of x is less than 0. That's what it means. Okay, now the condition says f of x is less than or equal to g of x. This is where f of x lies below and is also equal to g of x. Is either below or actually and equal to g of x. These two conditions have to be met. It has to be below and at the same time be equal to. By equal to, it has to touch g of x. That's what equal to means, touching the intersection of the two graphs, right? That's what that condition says. So now let me explain the condition f of x is less than or equal to g of x. I want you to look at this parabola and this linear function, right? So we want where f of x is less or equal to g of x, right? We want that region. So let's look at our graph. So let's start from the left. We always start from the left, from the negative numbers, because that's the order of numerical values. So we start here, right? We go pop, pop, right? Focus on this side, right? Focus there. What is above the other? The parabola is above, right? So we go right here. See, there's an intersection there. And let's go to our condition. It says where f of x is less than or equal to g of x. So we mark this point because it's also in the condition, right? This is where they're equal at -1. So let's mark it. We marked it. We marked that region by, there's a line there, right? So we go. You're looking at this side. You are here. Right? Ignore that other side. So let's go. What are you seeing here? We're actually seeing that f of x, which is the parabola, is actually below, right? You're looking at starting at this region, right? Starting at this dotted line. What are you seeing? F of x is actually below, and our condition is being met. So you're seeing what you want. You go on and on and on and on and on. You're looking at this side, right? You're looking at here, going to the left. Ignore everything you see right there, right? And then you move on and then see, our condition has been met again, right? This is where f of x is equal to g of x. You draw your line again. Right? So this is the region they are talking about. Exactly, that this is the region they're talking about. So if the question says, for which values of x is f of x less than or equal to g of x, you say it's right there. It's where x is an element of -1. You include 1 because the graph touches and the condition states that it should touch. You include because it actually touches. So -1 is part of the entire thing. That's where the condition starts being met. So you include -1, -1 up to 5. You include 5, right? Because it's also there, it touches. That's what the condition stipulates. If you don't like interval notation, you can use another notation. Actually, you can use the set builder notation, which I hated so much. So you could say your x is this. Look at this, understand this, right? When we start from -1, which direction are we going? We're going this way, right? To the right. If we start from -1, we go to that way, to the right. What happens to the numbers as you go to the right? The numbers increase. So your x is greater or equal to, because of that, right, is equal to there, right? And it touches on the graph, you know this. So is x is greater or equal to, because we're moving to that direction, x is greater as we move this way than -1, right? And then we go this way from 5 to this point. What happens? Your x values become less, right? So your x is less than or equal to 5, right? These are the two answers that you could go for, right? When you're using the set builder notation, you ask yourself this question: what happens as we move in this direction? Our numbers increase. It goes from -1, and then we have 5 there magically. So voila. So your inequality sign is greater than, because the numbers are becoming greater as they increase. And then the same thing here, they go down, you say less than, so x is less than or equal to 5. You include these numbers because there's intersection there, and the intersection is needed by the condition, right? And we also have this condition where f of x minus g of x is equal to k. This is where the distance from f to g, f of x minus g of x is equal to k, where the distance from f to g equals k. I'm actually going to do a question like this maybe tomorrow, because I don't want to feed you too much information. One step at a time, we're taking baby steps. And this is the distance, right? This is the vertical distance, where from f to g it equals k units, right? We'll do this question. And then we have f of x multiplied by g of x greater than 0. This is where both f and g are either above or below the x-axis at the same time, right? I'm saying this is where both f and g are either above or below the x-axis at the same time, right? It could be positive or positive. So your graphs have to be positive or positive. By positive, they have to be above the x-axis. Remember here, we said f of x is greater than 0, is above the x-axis, right there. That's what we said, right? So they have to be above the x-axis, both of these graphs, and then at the same time. That's what the condition means. Or they could be below the x-axis. When they're below the x-axis, the y values are negative, you know that, right? So if they're both below the x-axis, it's going to be negative times negative, which is equal to a positive. So the condition is still met. At the same time, this has to happen at the same time, at the same interval. We're moving at the same interval. Don't change intervals, right? I'm going to do questions that have these conditions so that you can see clearly. I'm not going to do them on the side. They're rather complicated. So let's go to this. This is where f of x multiplied by g of x is less than 0. This is where the other one is above, right? The positive indicates the graph is above, and then the other one is below. Negative indicates below. At the same time, same interval. We're talking about the same interval, right? If we're talking about the interval from x is equal to -1 up to x is equal to 6, that's the interval we're talking about. At the same time, it has to happen at the same time, right? Or where the other one is below, the other one is positive, right there. Or another case that we have is f of x over g of x is greater than 0. This is where they're both positive, right? Positive divided by positive, that's positive. When we're talking about these, right, f of x over g of x less than 0, the same logic that we use for the multiplication, it applies. What I wrote there and there, it explains this and this, right? This way is greater than 0 is the same thing as this. This way is less than 0 is the same thing as this. That's why I didn't write anything to further explain it. Yes, so I'm going to send you a picture of this. You need to know this by heart, right? So let me do the questions.